I wanted to take a moment and graph a few more inequalities for you. I didn't think one example problem was enough. So we're going to do 2 or 3 more example problems, however many I can get in 5 or 6 minutes. So I've got a second problem up here. 2y is greater than or equal to 4x plus 6, excuse me. Now, the first step is to graph it as if it's a line. Is it going to be easy to graph if it's not in slope-intercept form? There's a 2 in front of the y, isn't there? So we need to divide both sides by 2, because for graphing purposes, we need the y by itself. We need this in slope-intercept form. Okay, so after I divide both sides by 2, I get y is greater than or equal to 2x plus 3. Now the b value is 3, so I'm going to go up to 3. And the m value is 2. Don't forget, that means 2 over 1 for rise over run. So that means I rise 2 and run 1. Rise 2 and run 1. Now, another little quick thing that just helps us with graphing is if you end up going off of your paper, you could also consider this as -2 over -1, because a negative divided by a negative is a positive. That means we're going to go down 2 and to the left 1, and you can see down 2 and to the left 1, that puts us on the same line. Okay, just a little trick for graphing. Okay, now, we need to make this line. Should we make this line a solid line or a dashed line? Since it's greater than or equal to, we're going to make it a solid line. That means, hit my line there. That means that the points that land on that line are also solutions to the inequality. And now we need to shade. We're either going to be shading above it or below it. We're going to use a test point. So I'm going to put in 0, 0. Y is greater than or equal to 2 times 0 plus 3. Is 0 greater than, and when you do that calculation, it's 3. Is 0 greater than 3? The answer is no. So 0, 0 is on this side. This is the false side. It means we have to shade the other side, which means we're going to shade up there. All of the points that fall into this area will make it true. Let's pick one. Let's pick one like, all right here. 1, 2, 3, 4, 5, 6, 7. 0, 7. If we pick 0, 7, this is just for demonstration purposes. I want you to see that it makes sense in the 0, 7 area. So 7 is greater than 2 times 0 plus 3. 7 is greater than or equal to 3. That's a true statement, and notice it's in the shaded area. The false statements are the unshaded area. Okay, that's one problem. Let's see, let's do 4x is less than -12. 4x is less than -12. Freehand a graph right here. Not going to take the time to use my straight edge. All right, wait a minute, there's no y in this. The equations that only have an x, are they a vertical line or a horizontal line? Remember I said we should memorize this. They're a vertical line. Well, we got to get the x by itself. We're going to divide both sides by 4. X is less than -3. All right, so we're going to go to -3, and we're going to make our line. Our line's going to go right through, a vertical line, right through -3 on the x-axis. Okay? Wait 1 second, okay? So I'm going to do that, and I'm going to make this a dashed line because it's just a less than. Right there. Now, which side should I shade? Now, we don't really have a top and a bottom, but we have a left and a right. No. We're going to use our test point 0, 0 again. Here's our test point. 0 is less than -3. Is that a true statement or a false statement? That's a false statement. So we're not going to shade the 0, 0 side. We're going to shade this side right here. Okay? All right, one more problem. We're going to call her good. Oh, 5x plus 2y is greater than or equal to 10. And I picked this one because it happens to be in standard form. Now we have to graph this line. We could convert this line to slope-intercept form, or we can just use the little t-chart and put in the zeros, because we want to know, hey, where does it go through the intercepts? A little different method of graphing. So when I put in 0 for x, that eliminates that part. And when we solve this, 2y and 10, we would get y to be 5. When I cover up the 2y, I get 5x and 10, divide both sides by 5, and I get x to be 2. So 0, 5, graphs right there, 2, 0, graphs right there. Should I make it a solid line or a dashed line? Because of the equal sign, it is a solid line. Okay, it seems like every one of my examples I'm shading on the opposite side today. All right, I've got, when I put in 0 for my test point for shading, 5 times 0 plus 2 times 0 is greater than or equal to 10. Is 0 greater than or equal to 10? The answer is no, it's not. So again, a lot of my examples we've been shading the opposite side. If I pick a point over here, it'll end up being true, and it'll show you that's the side we shade. Anyway, there's a few examples. Do your practice. Good luck.